Welcome back, everybody. Steve from the Pinball Room. This is what we're going to be working with today. If you don't recognize it, this is a stepper motor, a NEMA 17 stepper motor, similar to what's used in 3D printers and lots of other technology nowadays. And this is the Pololu Tic, I can never say it right, Tic Controller. This little circuit board, this is a T825. This is what's used to hook up to a stepper motor. There's several different types of these. It's the one we're going to be using. And we're going to go through, we're going to control the stepper motor to go through and control our staircase and finally get that motorized and running so we can get ready for our upper play field. Now, I said this is a NEMA 17 stepper motor. This one's kind of big. This is a la the size that's inside the new Godzilla building mech by Keith Elwin and Stern, right? We've got a smaller form factor one, a NEMA 8 stepper motor that I'm going to try to use first, and I'm hoping it has enough strength and torque, given the right input, to be able to go through and move this plastic staircase we have here that we 3D printed. So yeah, stepper motors. How do they work? How do we make them work within a pinball machine? How do we get them set up and configured correctly in MPF, our Mission Pinball Framework, so that the software will actually know how to control it based on different events happening within the pinball machine itself? So that's what we're going to dive into today. All right, let's get right to it. So the first thing we should talk about is maybe really quickly just what is a stepper motor, and I'll do this as fast as I can. A stepper motor, like so many other things, there are a bunch of different windings of copper coils inside here, right? That when energized, control the motion of this axle. Stepper motors are great because they're known to be, well, they're relatively low speed in their ability to move. They're not super fast, right? You're not going to use a stepper motor to go through and run your RC race car, right? But they are very precise and they have very high torque. And when they're energized, they resist movement pretty well, depending on just how much power that they have in them, right? If you're powering it by like a 9-volt battery, you can still turn it with your hand, right? But hopefully with either 12 volt or maybe 48 volt from a high power supply, we'll be able to get this stepper motor to hold really strong in place so its position does not get affected by a ball whacking the mechanism, right? So high torque, low speed, but highly precise. They're called stepper motors because if you get a stepper motor and if you like grab it and kind of turn with no power on it, right, and you turn this axle, you can feel just like these little tiny little clicks, little steps. That's why it's called a stepper motor, there's little steps. And there's roughly in each basic stepper motor, at least like hobbyist level motors like these, there's about 200 steps built into it. But it can be controlled down to like half steps, quarter steps, even like 1/16 of a step, maybe even a 32nd. I'm not sure exactly just how precise you can get. I think it depends a little bit on your software and on your controller board. But so 200 steps is basically 360 degrees of rotation, all right? So if we want a quarter turn, we'd want about 25 steps, right? And the way we have our staircase model right now, a quarter turn is going to advance it 1 step. So that's where we're going to start, trying to get this all hooked up and connected to move it 1 step at a time to move the ball up the staircase. All right, so these stepper motors have 4 wires coming off of them. We're going to need to go through and talk about how we wire these up and how we get that set. So that brings us to the next step here. Again, this little controller board. This is off of pololu.com. And this is the T825 circuit board. This has a micro USB connection here. You plug it in your laptop with. And then it's already got pre-soldered pins here with these screw terminals where you'll be able to go through and add in your voltage in, your ground, and then those 4 wires from your stepper motor. And they're referred to as A1, A2, B1, B2. I've got some schematics we'll throw up on the screen that'll show you exactly how to go through and wire it, all right? So this micro USB controller is what's going to need to have a cable ran back to your computer that's running MPF and everything else, all right? So for us, it's our main laptop. So that wire needs to run off of there. And then, like I said, we need to have voltage in. I'm going to try with our 12-volt power supply first, and then we'll wire up those wires, okay? Now, a good way to do this before you just throw it in your computer up with MPF and try to get it running, you need to make sure you have the right software installed on your computer first. And so if you go to the Pololu website and look up the T825 controller or whichever controller you happen to buy, there's a couple of different options you can use. There will be a link down below. It says resources. Click inside resources. It gives you great instructions on how to set it up, how these work, how to wire them, and also links right to the Ticcmd control center software you'll need to have installed. That's also going to go through and install the basic drivers that you'll need in your machine. It's got options for both Linux and Mac and Windows OSs, all right, all 3 of them. And once you get all that set up and installed, and you have the drivers, you'll be able to connect this via USB, and it will recognize it's there. If you do it without your power connected, it'll tell you, hey, it's here, but we're disengaged because there's no voltage in coming in, all right? So here's a quick look at kind of what it looks like once you've got it done. I've had this just with a 9-volt battery, just so we can show how it works, right? We've got that coming in, voltage in, the black, and then the USB here dangling. And then if we go through and connect the stepper motor, and we'll jump over to our screen here, I'll show you the Tic command center, and we'll play around a little bit, and we'll show the stepper motor moving, all right? All right, so the first thing we need to look at is figuring out exactly how we've got to go through and wire this, all right? So let me throw up a couple of schematics on the screen really fast, and we're going to talk through those. All right, this is an image. It's kind of a couple images combined. The part on the left here on blue, this is off the Pololu website, where it goes through and shows the T825 Tic Controller Board that I'm using, okay? And it has an image like this for every different controller board they have. And the important part here is along the right-hand side here, kind of in the middle of the screen, where it has VIN for voltage in, 8.5 volts at 45 volts. That's the range of voltage input this controller can handle. There's a pin for the ground, right? And then we have the A1, A2, B2, B1 with these little yellow and green kind of lines going through and talking about how those need to come out of the actual motor. The M stands for the motor, right? Over on the right-hand side, we have another diagram from the actual stepper motor itself, which is the NEMA 8 motor that I had, and it shows A, C, B, and D, black, green, red, blue. There's 4 colors that come out of the stepper motor. They correspond to that. Black, green, red, and blue, okay? And so we need to go through, based on these diagrams, to understand which one of these needs to be plugged into A1, which one of these connects to A2, and so forth, right? So with these little blue arrows here, hopefully you can see that, right? So the black wire, which corresponds to A over here, should go into pin A1, into that connection. The green wire should go to A2, the red wire should go to B1 down here at the bottom, and the blue wire should go to B2, all right? So that's how we're gonna go through and wire them up here onto our actual control board. All right, we've got those wired in. We've got like a little flag so we can tell when the axle is turning. We've got our cheap power supply right now. This is 9-volt battery. As soon as we plug it in, we get some lights flashing a little bit to show we have power. We're gonna plug in the USB. Bing, bing, bing. Windows says we're connected. Now up here at the very top, it says connected to is the very first screen. We're gonna kind of zoom in here, right? If I open it up, it shows the T825 and then like the serial number. This is a 8-digit number that identifies this specific control board. You can have multiple control boards plugged into your computer, right? So I'm going to select that one. It says down here, it's been de-energized because of command timeout. Press resume to start. The green button, so I push that to start. Bam, here we go. Voltage in. I'm not sure how well you can see that, but it's fluctuating right around 8.9. And then down here, we've got this blue dot on this bar here. The set position. So right now it's saying it is at position 0. Right below it, set target position. I can type in a number. I can type in, like, I don't know, 120. I can hit set target position and then watch the motor over here. It's going to start turning. Boom, it moved to 120. And now if I go back to 0, it goes back to 0. And if I type 120 again, it goes right back to 120. So it's very precise every time. So this is a nice manual way to control your stepper motor, right? Just by grabbing the slider, I can make it move back and forth, kind of fun to play with, but not super practical, right? But it lets me test it, okay? And make sure that everything's working correctly, all right? Now, what we want to do, okay, what we care about, we will de-energize it. You never want to disconnect this from the circuit board while it's still energized. They're very careful to call that out. So we always hit the red button, de-energize, and now we can go through and unplug and disconnect it and remove this power source and everything, okay? All right, so we played around with the NEMA 17 motor, got the control center up and running for the software, and we saw how it was working. So we connected things correctly, it was moving. Now the next step is we've got to do 2 things. One, we've got to go through and get the smaller NEMA controller or motor that I have inside my pinball machine. I didn't want to take it back out. It's kind of a pain, it's all assembled. Got to get that connected and test it and make sure that the 12-volt power supply is going to be strong enough to get it to have enough torque to move that whole plastic staircase escalator that we have built in there. I tried it with a 9-volt battery. It's not strong enough, it won't move it. We're going to try it with a 12-volt, but we're probably going to have to hook it up to high voltage. So we're going to try that next and find out what power supply is going to work best to make sure it has the torque to actually move this staircase. All right, moment of truth. We have 12-volt right into the board. We have this wired up and plugged into the stepper motor, which is back inside here on the staircase. My laptop is running with the command center ready to go. We'll connect this via USB. Good lights there, little Windows chime, it has been connected. Now we power on our system. It is there. We're getting a steady 12 volts. Energize, and let's try to go a quarter turn. Not enough juice. It tried to move. See if you can hear it. Listen. It's got too much resistance. I mean, I can move it pretty easily with my hands, but this motor does not get enough power to actually move it. Yep. All right, attempt number 1 failed. We're gonna have to switch to high voltage power. It can handle up to 45 volts. That's what we're cranking out here. So let's hope that's enough. If not, we're gonna have to totally re-engineer this and use a larger stepper motor with a different bracket. That's gonna be a pain in the butt. So let's hope high voltage power works. All right, let's cut all this off. All right, here we go again. Connected. De-energize because no voltage. Power up. 48.2 volts. Resume. Go for a quarter turn. Not working. All right, I'm gonna have to pull this assembly apart and just test the motor. Motor either might have gone bad somewhere or just doesn't have the strength, or have to upgrade to a larger motor. This might be a longer video. All right, guys, time to disassemble. All right, that's all there. Device connected but de-energized. Give it power again. 48 volts. Resume. I felt it engage. Quarter turn. Let's see if you saw that or not. It turns. So it's not broken. Oh, but see, even energized, this just moves way too easily. So this motor just doesn't have enough torque. It's just too small of a motor. It just doesn't have the strength for the full staircase we have set up. Which means everything I thought we had figured out so perfectly, not so perfect. All right, because of the difference in the size of the housing around these axles, this one is much smaller and thinner, where this one is much fatter, right? And so the steps themselves on this one, they could just kind of like go around the housing and not touch. But on this one, they go around and they hit. And so I needed to get the axle and the gear far enough away that they wouldn't hit this. So I had to go from this gear that went on to this gear that has this extra space, so I can put it on the axle and it's snug. That way, once it's on, it's got this much more gap, so the stairs can circle around in here, the steps themselves, and not be hitting the housing. So now this one comes with a nice aluminum bracket to help mount it on things, okay? Long story short, we're gonna take this bracket, We're going to mount it, we're going to get the gear in place, and we're going to try again and see if we have success. All right, so I had to go through and 3D print off another piece here in order to get the gear, the teeth, right in the middle of where that track's going to be, right? This was the original piece, much skinnier, because I was able to mount the other motor closer in. This one's bigger, I have to mount it further back, so I had to kind of extend this piece here, kind of give it like a longer axle. But now we have that printed and we have it on there, so now we're going to hook it up and double check the power's running, and then see if we have enough torque to get this thing to actually work. Okay, de-energize, let's run some power. Resume. Why is this not turning at all? Another failure. This just isn't being driven anymore. So I don't know, at some point there was too much friction on it and I operated it and that just burned it out or what, I'm not sure. I have to try to troubleshoot and see what I can find. All right, so I think I found out what I did wrong. I think putting the 48 volt power supply onto a board that was only rated for 45 volts was wrong. And not just in the long term, but even more immediately, because I've now gone through and disconnected and connected back into a 12 volt power supply and got it set up again. And now it is running just fine. So hopefully it was just messing things up. Hopefully I didn't cause any damage to the motor or to the board. I've got replacement boards. I don't have a replacement motor yet. So yeah, anyway, good news, this is now working. And so we're gonna get this back on, this bad boy back on, and we're gonna hook it up and see. But I'm not impressed by the hold power. I'm wondering if this is gonna work. Or I was talking with another gentleman last night on the Fast Slack channel, is Dave Beecher, who's way more knowledgeable about all these things, and he suggested I might need to explore a DC motor to really get the torque that I need for this mechanism. There's just so much static friction between all these steps and everything that the stepper motor just might not have the power for it. So we got this working again. I'm going to try one more time and see if we can't get this staircase to turn, but I'm preparing myself for the fact that a stepper motor, while cool and precise, might not be the way to go for this particular mech. We might have to get a DC motor, so we'll see. We're going to confirm this is still working now that we've connected everything. The drive itself doesn't have too much drag. Do we see that? Did you see that? It turned. Let's get in here closer. Okay, it's turning. Now let's get the staircase connected. If you can see the gap here between this step and the play field, we're about a ½ inch lower now because of that thicker stepper motor in the different bracket than we were before. And so we're gonna have to adjust some things with how that's mounted down below to get that back flush with the play field. But for right now, we're using the exact same brackets and everything just to connect it, just to see if we can get the power to actually get this thing to run, or if this just requires too much torque. I mean, I've only got 4 teeth on each of these gears, so it's kind of relying on each one of those teeth to really be able to do its job, versus having 16 or 32 teeth on that gear. And I mean, that's fun what we're doing, experimenting, right? So let's see if it works. Let's flip it upside down, get the power going, and see if it'll turn. Flashy lights, we're good there. Get the power going. All right, we are connecting, re-energizing. And now let's see if it'll do a turn. Nope. Too much friction for it. All right. I'm trying to just loosen this a little bit, see if that helps. Okay, that's way looser right there. I'm gonna try it right there. Let's see. Maybe I just have too much. I have it pulled too tight and there's too much pressure on it, you know. So I'm just gonna loosen that. But think of this, if you think of the stairs here as like a chain on a motorcycle, right? Or a bicycle, it's like, how tight do you want that chain to make sure that the gears are moving slow and not binding? So once I tighten it back down, I'm just trying to loosen that chain and see if that'll fix it for us. Making it super loose isn't necessarily gonna solve everything, but hopefully I can at least find the right amount of tension, just find out what the limit of the stepper motor is as far as how much torque it can put in. But I mean, again, like a chain on a bicycle, if the chain is too loose, then it's really sloppy and it can slip gears. And we don't want this to be slipping gears, and because then it slips a gear and then it does start to bind on the next gear turn. And anyway, we'll see if we can find a happy medium here. I have to readjust my optical over there, but we'll worry about the opticals later. So there's definitely more play in this now. I'd say dangerously too much play. But again, let's just see if we can get the motor to work. All right, select our motor, re-energize, and let's try a quarter turn. Oh, it tried. Did you see that? It tried. Yep. Even this loose, it's like that's not even so much helping it, because now it's like so loose once it engages on a tooth, and there's just too much friction of what it's trying to pull. Stepper motor does not have the strength we need for this. Well, now you might wonder, really, my staircase mech could probably just be built in a much better fashion, maybe the number of teeth I have and all that is just a little too simple, a little too rough, and so all the different variables of friction and everything else are just coming in too much to beat me here. To be like, a stepper motor, like it's working great in Godzilla with that giant tower mech and everything, right? The thing you got to think about with stepper motors, though, is like, where are they primarily being used, right? They're being used in a screw drive of some sort, right? So for like a 3D printer, for a CNC machine, and they will twist and spin a little mechanism to bring something up and down, but like the Godzilla building mech, it's sliding on these nice smooth rods. There's really very little friction. If you removed it from the motor and from the belt and just slid up and down, like it goes really, really easily. There's no friction. It's just gliding on things, right? And so the amount of like inertia that has to be overcome to get that building moving is very little. And to hold it just in place with the screw drives or with that belt, again, not very much to hold it in place. There's not a lot of pressure moving it up and down. There's nothing yanking on it, right? So it's a great application there. But I think that at least the way that I have this staircase built, and some of you have given me tips on a different type of staircase, right? And I forget the name of it now. I'll throw it up. But the one where you've kind of got steps that kind of alternate up and down to move something up. Something like that might have a lot less friction, and maybe that's a better approach for this staircase. I really wanted like an escalator type approach, right? But either I'm going to need a stronger motor, a DC motor, or I need to re-engineer how I'm doing this whole staircase. So I don't want to re-engineer the whole entire staircase, but I don't have to at this point. I'm kind of pretty far along with this. So my next step is going to be to go through and get some simple DC motors and try with them and see if they'll have the torque. They should have a lot more torque and be able to drive this. But, I mean, again, at the end of the day, even with a higher torque, maybe the system I have is just going to bind too much. We'll see. We might have to iterate on that. So, I mean, I knew this from the very beginning. This custom mech was going to be the biggest risk of everything else working, right? Everything else we're doing are tried and true things, right? A flipper, a scoop, a drop target, a stand up, some optical sensors, like whatever, and bending ball guides. But when you get into custom mechs, yeah, it's tricky, as we're finding out, right? So, I don't know. We will. I'm going to throw this up because it's going to be probably a little while until I am able to get a DC motor in. I'll see what I can find on Amazon, but onward and upward, we got to keep moving. We've got a date of June 3rd in the Tacoma show, the Northwest area pinball and arcade show. So we got to get a machine there. So we've got to get this mech figured out. Our whole upper play field, everything else is dependent on this. So we got to keep moving. So we tried a stepper motor. Stepper motors do have their applications. They do work with Mission Pinball Framework, and they can, I think, be really helpful in certain situations. But it's not going to work with the mech I've designed so far. And either the mech is horrible, or I just need a better power source for this motor. Maybe the combination of both. All right, thanks for watching, and I hope you learned a little bit from this, and yeah, better luck next time, right, Steve? Okay, thanks for watching, guys. Catch you next time. Bye-bye.